So now in this video, we'll be looking at the Newton law of gravitation to try to understand it. So this whole chapter is based on this Newton law of gravitation. Newton law of gravitation states that all the objects in the universe, they are attracting each other with a force F. All the objects in the universe are attracting each other with a force F, which is directly proportional to the product of the masses of the two bodies. So, for example, if I consider that there are two astronomical bodies in the universe having mass m1 and m2. So there are two astronomical objects of masses m1 and m2. And suppose they are separated from each other by a distance r. So we are taking this distance from the center to center of the two objects. Okay. So A and B are the two objects of masses m1 and m2. So according to Newton's second law, Newton law of gravitation, sorry, this force is found to be directly proportional to the product of the masses between them. And this force is found to be inversely proportional to the square of distance between them. Okay, so this force is acting between these two objects like this. So M1 is attracted by M2 and M2 is attracted by M1. This force is mutual. So if I combine these two quantities, what I get is that F is directly proportional to M1, M2 divided by R square. Okay, or we can say that F is equal to G M1, M2 divided by R square. F is equal to G M1, M2 by R square. So here capital G is the constant of proportionality and is called the universal gravitational constant. So it is called the universal gravitational constant. Okay. We can define G also. Like for example, if I take M1 equal to M2 equal to 1, and if I take R is equal to 1, so what I will get? I will get F is equal to G into 1 divided by 1 square. Or you can say that G is equal to F. So universal gravitational constant is numerically equal to the force which is acting between the two bodies of unit mass kept at a unit distance from each other. Okay. See, gravitational constant, capital G is a vector quantity, is a scalar quantity. Capital G is a scalar quantity. And its value remains constant throughout the universe. The value of capital G is found to be equal to 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square. Okay. And since its value remains constant throughout the universe, hence it is called universal gravitational constant. And we can also work out the dimensional formula of capital G also. So if I calculate the dimensional formula of capital G, so how we can do that? We have our formula, Newton law of gravitation, which says that F is equal to G M1 M2 divided by R square. Okay. So that means capital G will be equal to F into R square divided by M1 into M2. So if I calculate the dimensional formula of capital G, so that will be equal to, what is the dimensional formula of force? The force dimensional formula is ML T minus 2 multiplied by R square. So R square is L2 divided by M into M. That will give you M2. Okay. So if you calculate it, you can easily get M minus 1 L3 T minus 2. So this is the dimensional formula of capital G. Okay. So this Newton law of gravitation, it holds good for any two objects. These two objects may be of any shape, they may be of any size or any mass. And this Newton law of gravitation holds good at all the places in the universe. It holds good at all the times, right? So this is the basic formula of Newton law of gravitation. So you can say what are the important characteristics of gravitational forces? So gravitational forces are existing, between all the objects in the universe. Characteristics of what are the characteristics of gravitational force? So number one characteristic is that it is independent of the medium between two objects. So if there are two objects and the force of gravitation between them is F is equal to G M1 M2 by R square. So this force will not be affected if the medium between the two objects is changed. Okay. And this gravitational force, it is independent of the presence of or absence of other objects. Presence of other objects. The other objects are not going to affect the gravitational force which the two objects are exerting on each other. Okay. So this force is independent of the presence of other objects. So what I mean to say over here is that if there are two objects of mass m1 and m2, so they are attracting each other with the force F. So this force will not be affected if I bring another object of mass m3 near m1 and m2. Okay. So these forces are going to maintain their individuality. So this is also called the principle of superposition. One of the features of the principle of superposition is that the force between the two objects is not affected by bringing a third object near these two objects. Okay. And principle of superposition also says that the force which is acting on any object in the space, so if there is an object m naught placed in space and there are other objects also around it of mass m1, m2, m3, m2, m3, m4. So these masses are going to attract this m naught with force F1, F2, suppose F3, F4, etc. Then principle of superposition says that the total force on mass m naught will be the vector addition of all the individual forces F1 plus F2 plus F3 plus F4. So this is the principle of superposition. Okay. So now coming back on the Newton law of gravitation, another characteristic of gravitational force is that this force is independent of the nature and size of bodies, independent of the nature and size of bodies till their mass remains same and the distance between them, between their center is also fixed. Then these forces, gravitational forces, they also obey Newton's third law of motion. So they form action-reaction pairs. They form action-reaction pair, right? The fifth characteristic is that the gravitational forces, they are central forces. The gravitational forces are the central forces. So if there are two objects of mass m1, m2, we have said that these two forces, these two objects are going to attract each other with the force F. So Newton's third law is obeyed. For every action, there is equal and opposite reaction. And here action and reaction are acting on different bodies. And these gravitational forces are acting on the central line joining the two bodies. So that's why they are called central forces. And very important that gravitational forces are the conservative forces. They are conservative forces because the gravitational field is a conservative field. the amount of work done in moving the body from one point to another point in a conservative field does not depend on the path followed, but it depends only on the initial and the final position. So you can say that gravitational force is the conservative force because it is acting in the gravitational field. Okay.